Good day to you all. In this lecture, we learn about some basic definition of Earth's magnetic force. Let's start with magnetic lines of force. What is magnetic lines of force? Magnetic lines of force is the imaginary line or imaginary path followed by a standalone magnetic north pole or magnetic south pole. What is magnetic meridian? Magnetic meridians are the imaginary line which connects magnetic north pole and magnetic south pole. We can see that this on the screen. These magnetic meridians are connecting magnetic north pole and magnetic south pole. In the real world, these magnetic meridian and magnetic lines of force will fall over each other. Right? Let's discuss about angle of dip. What is angle of dip? If we freely suspend a magnetic needle, it will create an angle with the horizontal at any place of the earth. That angle is called the angle of dip. Right? In the screen, we can see that if we keep a magnetic needle, it will try to align itself with the magnetic meridian. Therefore, it will create an angle with the horizontal. That angle is called magnetic dip or angle of dip. Right? So, in the screen, we can see that these magnetic needle are creating angle of dip with the horizontal. Let's talk about magnetic meridian. What is magnetic meridian? In some places of the earth, you will see that if we keep a magnetic needle, it doesn't create any angle. It remains horizontal with the earth surface. That those places, if we connect together, that will create an imaginary line which will be close to the earth's equator, and in that line the angle of dip will be 0. That imaginary line is called magnetic equator. Now, in the screen, we can see that a magnetic needle is kept horizontal and it is kept on the magnetic equator. So that's why it remains horizontal with the earth surface and it doesn't create any angle. So in the magnetic equator, the angle of dip is 0. Now, if we take this magnetic needle to the northern hemisphere, what will happen? It will try to align itself with the magnetic meridian. As it is trying to align itself with the magnetic meridian, automatically it will create an angle with the horizontal. Right? So the magnetic north pole of the magnetic needle will create a downward angle with the horizontal, and that angle is called angle of dip for that magnetic needle. Now let's take that magnetic needle to the southern hemisphere. So here you see in the southern hemisphere, it will try to align itself with the earth's magnetic meridian, and therefore the blue pole of that magnetic needle will create an angle with the horizontal downward angle, and that angle is called angle of dip. Now in the screen, we can see a dip meter which is used to measure the angle of dip. Now, if we take this dip meter in the northern hemisphere, what will happen? That dip meter, in the needle in the dip meter, it will create an angle. That angle is called the angle of dip. Here, we can see that in the screen, as it is taken to the northern hemisphere, there it is creating an angle in the dip meter.